Okay, a geometric sequence, right? Yesterday we talked about arithmetic ones. Today we have geometric. You'll notice if we have a geometric sequence, if we have a common multiplier, or in this case, we call it a common ratio. If we are multiplying by something to get from term to term, multiplication, or if it's division, then we have ourselves a geometric sequence. So division means we're multiplying by a fraction. So if we're dividing by 2, that's the same as multiplying by 1/2. Okay, so we won't ever have a division sign as a ratio. You will have a fractional multiplication though. And this is your formula. We always start with the first term. That's important, a sub 1. Right? A sub 1 is your initial value. It goes directly into your equation. Times, sometimes you'll see this in parentheses, sometimes you won't. So I'm going to put it in parentheses just for fun. And this is your ratio, the thing that each term is being multiplied by. Okay, your common ratio. And then we're going to raise it to the n minus first power. Okay, so multiplication can be thought of as an exponential, right, where your ratio is the base of your exponent, and a sub 1 is the y-intercept, where it is across the y-axis. Okay, so we've done these things in algebra, but now we're going to put them together with some numbers. So here we have a sequence, 2, 6, 18, 54. So hopefully you notice that this is not a common adder, right? So 2 to 6 is plus 4, and then plus 12, and then plus, I don't know, is that 26 or 36 or something, right? So clearly this is not an arithmetic sequence because we are not adding together to get our terms. So from through 2 to 6, I do what to number 2? I multiply by 3. And then from 3 to 18, multiply by 3. From 18 to 54, multiply by 3. That means our common ratio is multiplying by 3. We get any term in our sequence simply by multiplying the previous term by 3. Okay, and then our first term is going to be 2. Right? Because that's literally the first term in our sequence. So we can write our formula to generate any term, g sub n, right? G for geometric. Yesterday was A for arithmetic, so G means a geometric sequence. Is our first term, which is 2, times our ratio, which is 3, raised to the n minus first power. So 2 times 3 to the n minus first. Okay, I put it in parentheses because it really helps us see the PEMDAS, how we're going to evaluate it. So what would be the 10th term? Let's just talk about this real quick, our PEMDAS. What is the 10th term in this sequence? Okay, you're probably going to need a calculator unless you're really good at powers in your head. Or, yeah, you're going to need a calculator. So, according to the formula, this is 2 times 3 raised to the 10 minus 1. 10 minus 1 is the 9th power. Okay? So this is our formula that we're going to plug into your calculator. Now, PEMDAS says we first do the powers. So we're going to figure out what 3 raised to the 9th power is first. So if you have a fancy calculator, that looks like this. We would do the 3 button, and then we would hit the arrow up button, okay, called your caret button, and then we would hit 9. And that's how we're going to get 3 to the 9th. Okay, so my calculator says this number is 19,683. And I still have to multiply that number by 2. Okay? So whenever we're evaluating this or we're finding some random term down the road, we do the exponent first, and then you multiply it by the first term. So in this case, my 10th term would be 39,366. Okay, that would be the 10th term in this sequence, starting at 2 with a common ratio of 3. Here we see division is still geometric because we're multiplying by a fraction. Okay, so if we have 64, 16, 4, 1, what is my common divisor in this case? It's we're dividing by 4, right? Every term is divided by 4. So we have a ratio of 1/4, right? That's what it means to divide by 4. This is the same thing as multiplying by 1/4. Division by 4. And our first term is 64. So our equation would become, right, g sub n equals our first term, 64, times our ratio of 1/4 to the n minus first power. Okay, so this would be the equation that we use to generate any one of our terms in our sequence. Okay, like for example, maybe the 10th term, g sub 10. Okay, so once again you plug the 10 into here. This is where our variable n is. 10 minus 1 is 9. So we're really looking for 64 times 1/4 raised to the 9th power. So this is what's going to go into our calculator first, 1/4 to the 9th power. And what your calculator is going to do, it's going to multiply 1 by itself 9 times, and it's going to multiply 4 by itself 9 times. Okay, and when it does that, it comes up with this fraction, 1/, let me see if I can do this in a second, is 262,144. Okay, so that's 1/4 to the 9th. 1 to the 9th divided by 4 to the 9th. And now in my calculator, if I multiply this by 64, I get the reduced fraction of 1/4096. So if I were to keep dividing these terms by 4, right, I would have 1 divided by 4, which is 1/4. Then I would have that divided by 4, which is 1/16. And then I would have that divided by 4, which is 1/64. In other words, I'm now multiplying my denominator by 4 every time. And eventually, I would get down here to 4,096. But the formula makes it a lot easier to do that rather than just trying to do it divided by 4, divided by 4, divided by 4, all the way down. Let's see if we can do this with our geometric sequence. Okay, so because we have an R, we know that it's going to be geometric, right? That's the ratio. If this were to have been a D, then that would be arithmetic, a common difference. So our first term is 5. That's pretty obvious. Our second term is found by multiplying our first term by -1/10. Okay, so if we were going to do this algebraically, this would be -5 divided by 10, which reduces to -1/2. So our second term is -1/2, right? This is the mathematical way of doing it. So the third term is the second term times -1/10. Right? We're taking whatever term we have and we're multiplying it by the ratio in order to get the next term. So we do fractional multiplication by doing numerator times numerator and denominator times denominator. Negative times a negative is now a positive. 22 times 10 is 20. So we went from 5 to -1/2 to positive 1/20th. And then our next number will be a negative, right? Because we're multiplying a positive times a negative. 20 times 10 is 200. So we have 1/2 and then 1/20th and then negative 1/200th. And according to this pattern, our next number will be, right, we're basically adding a 0 to our denominator. Positive 1 over 2,000. Okay, so some of these problems want you to write the first terms. So we're going to multiply each term by the ratio, right? We don't have to use a formula to do this. We can simply use our brains and multiply the previous term times the ratio. So we would have 5 and then negative 1/2 and then positive 120 and then negative 1 over 200 and then positive 1 over 2,000 and then dot, dot, dot. Okay, that's what our answer would look like if we were to list our terms in the correct ratio. Okay, here we're given some information and we want to find some random term down the line. Okay, so we can do this a couple of ways. Number one is simply by writing out our terms. So we're going to multiply this by 3. So 1 times 3 is negative 3, times 3 is negative 9, times 3 is negative 27, times 3 is negative 54, times 3 is negative 162. Is that 6 yet? 1, 2, 3, 4, 5, 6. There we go. That's the 6th term. So if the math is not too difficult and you're not going out to the 45th term or anything ridiculous, then using your elementary skills of simply multiplying each term by the ratio is a pretty decent way to do it. Now, if you want to be mathematical about it, right, the 10th term, we can also use a formula. Sorry, not the 10th term. We only want to find the 6th term. So this is going to be g sub 6, which means our power is going to be 5. Negative 1 times 3 to the 5th power. Okay, and I'm sure you can probably guess 3 to the 5th power is 162. And then you multiply that by negative 1 and you get negative 162. Okay, so this way we have a calculator, unless you know your 3's really well, your 3 powers. Whoopsie whoops. I'm glad we have checkers and double checkers and triple checkers and chubby checkers and all the checkers. So 27 times 3, that's what I meant to do. That's negative 81. And then negative 81 times 3 is 243. So that, my calculator, see, it would help if I looked at my calculator to begin with. But there you go, multiplying by the correct number. Maybe it's difficult or more difficult than we initially thought. So on this type of a problem, we are not told the ratio, right? We're not told the ratio. So there's a couple ways that we can do this. Number one is by guessing and checking, right? So we know the first term is 4, so there's our first term. And then we're missing our second term and our third term, but we know the fourth term is 1/2. Okay, so some things we can figure out. This is definitely going to be not multiplication, it's going to be division. Right, so we need to get to a 4 and divide it by something, and then divide that by something, and then divide that in order to get to 1/2. So what if we divided it by 2, right? So we're just going to guess, and we're going to see, right? We're going to guess and check. So our guess is maybe we're dividing by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. So sure enough, my guess of having a ratio of divided by 2, aka multiplying by 1/2, worked out pretty okay. All right, so it's an okay way to do this if we have simple numbers that have a simple ratio. right? As things get more complicated, this may not be the best method to find out what we're looking for. So we're looking for the 10th term. So g sub 10 is positive 4, our first term, times 1/2 to the 9th power. It's always to the 1 less power than what we're looking for in your problem. So g sub 10 means we have the 1/2 to the 9th power. Okay? So I'm going to take this 1/2 and I'm going to put it in my calculator and raise it to the 9th power. And that gives me 1/512. And I need to multiply that by 4. In other words, do I divide, is this nicely divisible by 4? I'm pretty sure it is, right? If it's divisible by 2 and 4 is in there. When I multiply this by 4, I come out with 1/128. So this would be my 10th term of my sequence. Now, I said that there's another way, and that's by using our formula. Okay? We know that the 4th term is 1/2. The 4th term is 1/2. So we're going to put the 1/2 on the left side of our formula. Right? This is our 4th term. We know the first term is 4. We don't know the ratio, but because we have this as a 4, we know that it's raised to the 4 minus 1 power. Okay, so this is using our formula. The nth term equals the first term times the ratio to the n minus 1 power. We know that it's n value of 4, so the 4 goes up here in the power, and we know the 4th term itself was 1/2. So we can do some algebra and solve this for r. So let's divide both sides by 4, aka times by 1/4. 1/4 times 1/2 is 1/8 equals r to the 3rd power. 4 minus 1 is 3. Now, if I want to solve this for r, I need to take the root that's the same as the power. So I'm going to take the 3rd root of both sides. The 3rd root. Okay? So that gives me my r by myself, but now I need to think about what is the cube root of 1 and what is the cube root of 8. So what numbers multiply by themselves 3 times to give you 1? Well, that's always going to be 1. And are there numbers that multiply themselves 3 times to give you 8? And that's 2. 2 times 2 times 2 is 8. So both of these are perfect cubes, so I get a ratio of 1/2. Right? So maybe the guess and check method would work better for your brain if you don't understand that algebra. Okay? Because sometimes taking a root of a different power is hard for students to do. Okay, so geometric sequences have a common multiplier, whereas arithmetic sequences have a common addition problem to them.